Hey guys, so from many days now, I was thinking to do a start from the scratch type of video on generative AI, and I'm here today talking about beginner's guide to generative AI. So this video will all be about starting from the scratch. We'll talk about traditional AI systems. We'll talk about how did generative AI come into the picture. We will talk about large language models, GPT models. We will talk about what is machine learning and different layers of artificial intelligence. And we will also touch upon some of the trending concepts, like vector databases, fine tuning, retrieval augmented generation. Okay, so let's get started. So if you don't know who I am, if you're new here on my video, my name is Pawan Belgati and I'm a developer evangelist currently working at SingleStore. I create a lot of content around AI, ML, data science, and DevOps. You can find my articles on different tech publications, and recently have started my YouTube channel. I need your support. So um, if you're new, go ahead and please subscribe. And you can also see my other videos that I have created on different AI topics. So yeah, so today's agenda is all about, we'll talk about AI systems, the different AI layers, Gen AI, machine learning, ML models, how ML models are different from Gen AI models, how Gen AI works, some different Gen AI tools. Like I said, we'll talk about large language models, retrieval augmented generation, vector databases, semantic search, and also I'm going to talk about single store database at the end. Okay, so yeah, so let's talk about the traditional AI systems. Okay, so you might have used Alexa and Siri, right? Alexa from the device at your home and Siri from your phone. So these are the we already know these are AI systems. These are AI. There are AI devices, but we need to understand one thing, that how these AI systems are different from Gen AI systems that we are talking today, right? So these traditional AI systems are basically, perform specific tasks with predefined rules and patterns. They only know whatever is fed to them by the engineers that worked there, right? So if you ask Alexa or Siri to create new content or try to generate a blog or try to summarize a blog or try to um, come up with a new song, generate some audio, video, or even an image, it doesn't do that. These systems can't do that because they already know certain things to do and they stick to that and they don't generate anything new, right? So that is the main difference between AI systems and the generative AI we are talking today. So like the word suggests, right? Generative AI. So these generative AI systems generate something new, right? If you give it a piece of query on, if you ask it, hey, can you generate something on the word cat, something on the word dog? Can you generate an image, right? Dog dancing on the streets, or cat eating a meal at a restaurant. So these generative AI models have the capability to do that. But whereas the AI systems, Alexa and Siri, they don't have that capability to generate something new. So that's where the traditional AI systems or tools fail. Okay. So let's talk about the different layers of AI. Okay, so at the larger picture, there is artificial intelligence, and under that, right, how machines learn. That is through machine learning. And then under machine learning, we have deep learning, which is kind of black box. There are neural networks that help there. And under deep learning, we see generative artificial intelligence, and that's where we are more interested in. And under generative artificial intelligence, what we call Gen AI, we have large language models. And under large language models, we have pre-trained transformers. That's what we call GPT models, right? And under GPT models, we have GPT-4, now GPT-4o, that is a new model from ChatGPT. Okay, so as you can see, a GPT is a deep learning model that uses transformer architecture to generate human-like text. So we're gonna talk about the transformer model and other concepts in the next part of this video. Okay, so yeah, why you see there's a lot of buzz and hype. I don't call it a hype, it's becoming a reality, right? There's a rise in Gen AI in the Gen AI world. I mean, every company today wants to embrace Gen AI, want to build autonomous AI agents, LLM powered applications, right? So if you go to Google Trends and try to uh, add this word Gen AI and see the trend, how it's growing from 2023. If you see, it's just growing up and above. So, like I said, right, with new models coming up every now and then from these companies like OpenAI, um, Google, Microsoft, Anthropic. So we are actually these companies are actually taking the bar high and with their superior models, and that's what giving rise to all these Gen AI related things, right? So you can go to Google Trends and try to search for this keyword Gen AI, or you can search for generative AI, and you will see how the search term or how the world is looking at this term and how it is growing. So yeah, let's get back to our layers, different layers we were talking about, right? And one of the layers in artificial intelligence is machine learning. Okay, so how machines learn, right? It's basically using machine learning techniques. So ML is a subfield of AI and gives computers the ability to learn without explicitly programming. See, programming is one part of how computers learn, but in machine learning, right? It's all about these techniques, right? Supervised learning, semi-supervised learning, and unsupervised learning. All right. So these are some of the techniques that how machine learning models learn. Supervised learning, as the name suggests, there will be a human involved in with a label and a data, saying to telling to the computer or the machines that, hey, this is dog and this is the dog picture, right? The text and the image. So that will be fed in the supervised learning, right? And in unsupervised learning, the models learn, themselves over time. When you feed some data, they learn over time. There is no any human involved. Whereas semi-supervised learning, as you can see, there is deep neural networks are involved here. We're going to talk about deep neural networks. So semi-supervised learning involves supervised and unsupervised learning, the mixture of both. And also there is a deep, what do you call, neural networks involved. So let's get to our layers. Under machine learning, we have deep learning, right? So deep learning, that is where we see these neural networks. You might have seen this image, right, on the internet and in many presentations, right? So there is an input layer and there are a lot of multiple hidden layers and there is an output layer. So this is about the deep neural network that usually that's where deep learning comes into the picture. So let's understand how these neural networks work. Basically, their main goal is to predict the next word, right? In a sequence. For example, here, as you can see, cat sat on a. It says that Matt is the next possible word, and it is 90% accurate. Okay, so that's how neural networks basically work. They basically predict the next word. Okay, so nobody knows what goes in between these multiple hidden layers. So it's just like a firecracker. You just ignite it, and there are a lot of activations that happen in between in these multiple hidden layers, and basically you will get an output guessing the next word or predicting the next word. Okay, so again, you can try it like about the neural networks. How you can try is take your phone and open your messaging app and you try to type in hello, how are, and the next word it's gonna predict you, right? Your things. You might have seen this in your own messaging application, and if you type in go on typing the next word, and the right hand side, what you see, you will see something like this: hello, how are you feeling this week, and your kind wishes for a wonderful weekend with your kindness and all this. But if you read it all together, it doesn't make sense sometimes, right? So that is where neural networks fail. They are good at predicting the next word, right? But they don't get the context. Okay, they don't carry that context, right? And that is when, you know, Google researchers published this wonderful research paper called "Attention is All You Need." You know what they said? They said like they propose a new simple network architecture, the transformer architecture, based solely on attention mechanism. Like we saw, right? This what do you call, neural networks did not carry any context of what happened, and they did not carry any self-attention mechanism. They didn't know, they were not aware of what's happening, but they were only good at, predicting the next word. That is when the transformer model was introduced, right? So how does a transformer model basically works? As you can see here, if you feed it with a story, right? The transformer model basically guesses the next word using self-attention mechanism and also with context, right? It will take that word that it produced as an output and it takes as an input again. If you see, write a story once upon a, and what could be the next once upon a time. So once upon a time in a forest or something like that. So that's how the what do you call, the transformer model basically works. And as you can see here, right, more detailed example. My name is, and my name is Pawan. So it takes the output of the first it takes the output and it takes it again as an input, right? It takes output as an input, and again it tries to predict the next word, so the sequence of the next word with more context, and then self attention mechanism. So, like we discussed, right, how traditional neural networks were different from transformer model. As you can see here, right, there was just feed forward happening in the traditional neural networks. They were very only good at predicting the next word without any context. Hello, how are you? Whereas in the transformer model, there was encoder and a decoder, right? Um, Tell me a story. It used to actually generate a new word with a context and with the self-attention mechanism. Again, take that output as an input, again, predict the next word. That's how it starts learning and also predicting the next word. So we saw under machine learning, the deep learning, where neural networks played an important role. And now under deep learning, we have a generative AI. That is what the world is talking today, which is all the buzz. So let's see what is generative AI, right? So generative AI is a type of artificial intelligence, like we saw, right, in the layers, in the big layer that is artificial intelligence, right? So that's where somewhere in between generative AI comes in under machine learning, deep learning. So it's a type of artificial intelligence technology that can produce various types of content, including text, imagery, audio, video, and synthetic data. So, like we discussed in the first slide, right, the difference between the traditional AI systems and the generative AI systems. This is the difference. These generative AI systems generate new content, or in I said content in any form, right? Audio, video, right? Whereas the traditional AI systems, they are all fed with specific data and trained on specific things, and every rule is predefined, right? So they don't generate anything new, like I said, right? So generative AI, you can see OpenAI models, GPT, DALL-E, and Codex. These three models, different, with a different output. GPT basically is text generation, DALL-E is for image generation, and Codex is for code generation. So that's the main difference of generative AI and the traditional AI systems. So how ML models are different from Gen AI models. So we also have machine learning models, right? But Gen AI models are more superior than machine learning models, and you can see it here, right? As you can see, there is a data and labels in the machine learning model. Basically, the model learns relationship between data and the label. That's it. And the output, if you see here, for example, there is a data and label of, for example, dog. The data is dog and the label is an image of the dog. And it basically, when you feed it to a machine learning model, it basically learns the relationship between data and label. And the output, if you ask it, hey, is it a dog? It'll just show, yeah, it is a dog. It doesn't generate anything new. Whereas in the generative AI model, as you can see, unstructured content, that is the image of a dog, if you feed it as an input to a generative AI model, it learns the patterns in the unstructured content that we provide. Okay. It basically tries to understand what dog likes, what it eats, what it doesn't like, what are the traits of a dog. And the output can be, if you ask it, hey, can you generate some new content? Can you generate an essay on dog? It can generate a new content. Okay, so that is the difference between the ML models, predictive ML models, and the generative AI models. So, and also we have come a long way, okay, from traditional programming to neural networks to what we call Gen AI, generative AI now. So we used to how it started, right? We used to hard code everything in a in an application, right? Type it's cat, type is animal, legs 4 ears, two for yes, likes yarn, catnip. But then we came to the machine learning models where there was a data and what do you call data and the label. It use we basically fed the machines with the data and the label, right? That's how the machines understood, and that's how they learned in the machine learning models, right? And if you asked the model, the machine, right, is this cat? And it used to predict, yes, this is cat. If you show it a cat or a dog, right? So depending on whatever is fed to it. But then now this is where we are. We see generative AI models like Lambda, Palm, GPT, etc. If you ask it to like, hey, go read this huge pile of books, it'll go read all the books. And so if you ask it like these models, hey, now you know a lot about cats and dogs. Can you write an essay? Can you write 1,000 words blog about cats or dogs? So can actually generate that. So like how that's how we have come a long way from hard coding to machine learning models predicting things, and then to the generative AI models today, what we see today, which actually generate new content. Okay. So how Gen AI basically works, the traditional AI, like we saw, images of dogs, trained model, it just discriminates whether it is a dog or a cat, right? If it's a dog, if you feed it a dog, it will just say, yes, this is a dog, right? And whereas in Gen AI model, the trained model on text from various sources, if you ask it to ask a prompt, a query like what is dog, it's actually gonna explain what is dog. Whereas the traditional AI models don't do that. And these are some of the Gen AI models, what we call ChatGPT, Gemini, Midjourney, Stable Diffusion, and Delay 2, right? So let's talk about the large language models. Like the name suggests, right? These models are trained on huge data set, lot of data from the internet, from videos, Wikipedia, anything, right? So that's how we need these LLMs, right? So generative AI applications are built using these LLMs. That's why we need these large language models. So for any query, we need LLM, and then the LLM actually has the ability to respond back to the user. So now we understood LLMs. Let's talk about what these LLMs are actually made up of, right? What are the components of these large language models, right? So they're basically, like I said, right, the content from various from the internet, that is data, and there is an architecture that is transformer architecture that we saw, and then some some training with maybe uh, some more training. So all these things are the components of a large language model: data, architecture, and training. Um, Training can be, using some humans. Reinforcement learning from human feedback is what we call, and that's how the large language models are made up of, basically. The data from various sources. Architecture, what we saw, the architecture is basically the model, the transformer model, and then the training. And then these large language models are basically, when they are trained, they can adopt to doing any specific task. They can actually do creative writing. They can do question answering, and then text summarization, language translation. They can do sentiment analysis, interactive conversation, and information retrieval. So that's how important the large language models are, and that's why most of the companies today are incorporating large language models in their support activities to build the infrastructure, automating the infrastructure, a lot of automating repetitive tasks and all these things. Okay, so yeah, so how LLMs basically learn, right? So I have taken this particular image from Andres Karpathy's um, uh, video, and I found it really interesting. First thing is pre-training. Uh, you download 10 TB of text from the internet. You get a cluster of 6,000 GPUs because you need computation power to basically train the model, and then you compress the text into a neural network, pay around 2 million, and wait for 12 days that these neural networks learn everything from the 10 TB of text, and using the computation power that we have given, right? 6,000 GPUs, and then you opt in a base model. Now, the base model just has all the, it has learned everything from the internet, but there is no alignment as such, right? To use it. It knows everything, but it is not aligned properly. That is where you need the second step, that is fine tuning, right? Writing, labeling, write labeling instructions, hire people. That's where you hire a lot of people, and you basically fine tune that pre-trained model on your own data. You again give it some more custom data, right? Think, for example, you are working in a healthcare sector on healthcare application, right? The LLM doesn't understand your vocabulary. That's where you need to give the LLM the context and the data, right? Custom data that it can understand the healthcare type of vocabulary and the words, right? Then you fine tune basically, and then wait for a day or two, and then you obtain an assistant model that can help you basically. And then you basically run a lot of evaluations, you deploy it, and you basically monitor and collect misbehavior, and then again go back to the step one. You fine tune it so much that there comes a time it starts understanding what you exactly want, and then it tries to produce the results or the responses that you want. So yeah, that's how even ChatGPT training process is done. Like internet text data, a lot of documents, they go inside this generative pre-training. This base model thing like GPT that was trained on a bunch of stuff from the internet, right? And then um, you do supervised fine tuning, right? Next, with the human AI trainers, you get to have conversations where they play both sides, you and an AI system, in an AI assistant, right? And then now you get a fine-tuned chat GPT model. Now what? Now we want to take it to the extra level, doing reinforcement learning through human feedback, right? You get some humans experts, and to take the model to the next level by optimizing it even more with reinforcement learning, by training it against a reward model, right? So that's how you got at the end chat GPT model, what we use today, right? So that's just an overview. That there are many different steps that go in between, but just an overview. We understood large language models, how they are trained, but these large language models have limitations. Yes, you might have seen, right? When using ChatGPT, beginning and even now, when you ask something, a query, sometimes it might hallucinate. What do you mean hallucinate? They might answer, the LLMs sometimes answer inaccurate uh, responses, right? They produce inaccurate responses, sometimes made up answers, sometimes, right, sometimes biased answers, which are not expected, which we don't want to use, because blindly if we use these LLMs in our applications, then we tend to, fooling it's like fooling our customers, because we know that sometimes they hallucinate. So it's very important to understand and evaluate these large language models, right? Because they are missing the context, because they're not tailored outputs, and sometimes they don't have that specialized vocabulary. So we need to make sure they have this context, they have the tailored outputs that we want, and they have that specialized vocabulary. They don't hallucinate. That is the intended behavior of the large language models. But we need to make sure, we need to mitigate this behavior of the large language models. So what we need to do, right? So yeah, before that, we this is the hallucination leaderboard I saw in one of the by Vectora. GPT-4, as you can see, that's the more accurate one compared to others. Like hallucination rate is 3%, and GPT 3.5, the accuracy is little less compared to GPT-4. And we have Llama 2, Llama to 70B, trained on different parameters, right? So we need to reduce we need to mitigate this hallucination behavior of large language models. So there are possible solutions. These are the solutions, right? Fine tuning, prompt engineering, and retrieval augmented generation, correct? So let's talk about these one by one. So what is fine tuning, right? You take the base model, and you you actually train it on your custom data, because base model is already trained on a huge data set, but there is no alignment as such so that you can use it for your use case, right? Now you need to feed it with your custom data that you have, your documents. Then it will try to understand the vocabulary, try to understand the personality, and try to produce the results or responses according to what you want. And yeah, this is how fine tuning basically works. Pre-trained model, uh, and you feed it with the domain specific data set, and now you have fine-tuned LLM, and that's how you can use it in your application. And the next one is prompt engineering. So prompt engineering is basically the art and science of playing with the prompts, different prompts, seeing, hey, if I use this prompt, what is the response? If I use the different prompt, different query, different, if I ask the LLM in a different way, what will be what will be the response? What will be the answer? So depending on that, you basically perform different prompts, right? So that's about prompt engineering. And then we have retrieval augmented generation, right? What we call a RAG. This is where you augment your LLM or the AI application with a custom data that is stored in a database, specialized database called vector database, as you can see here. So when a user query comes in, it gets converted into an embedding model which goes through the vector database to retrieve the relevant chunks. And then when it retrieves the relevant chunk, right, it doesn't go anywhere. It just goes through your vector database. That's why vector databases are very important, right? And through semantic search or vector search, different methodologies, it retrieves the relevant chunks, and again that chunk go through the large language model to answer back to the user. So that's about retrieval augmented generation. So as you can see, here is a simple RAG workflow. Um, it's a systematic workflow of a RAG where the user query comes in. He comes up with a question, which goes through an embedding model, and then it goes through the vector database. The query goes through the vector database to find the relevant chunk from the vector database, and and then you get the retrieved chunks with a full prompt. They go back again through an LLM to respond back to the user. So as you can see here, a vector database is very important because that is where all the knowledge source is stored here in a RAG system. Okay, and yeah. So how vector databases basically store data? If you give it a big document, they basically chunk that document into small pieces, and each piece is assigned with a numerical value. Okay, and for example, dog and puppy, and which can be represented in these numerical numbers, right? Which we call vector embeddings. And in a vector database, similar type of words are placed closer together. Okay, like this puppy, dog, they are more similar with the context, and that's why they are placed closer together. Tea, coffee, milk, they are more closer, and I mean, they carry more or less liquid, and they carry the same thing, the same context. That's why they are placed closer to each other in a vector database. So yeah, you can create vector embeddings easily. For example, for if you see Hello Earth, you basically should have a embedding model and text ready. So for example, here the model is text embedding ADA002. It is from OpenAI, and then if the input is Hello Earth, you're gonna get the vector embeddings created, right? So you can change the input, and also there are many embedding models from different platforms like Cohere, Hugging Face. All these platforms also give you these embedding models where you can convert any text into vector embeddings. Basically, the text gets converted into numerical value, right? So that's it. And again, the same vector embeddings. That's how they are stored in a vector database, right? The if you see the word apple and the numbers, that's how it's just an hypothetical example, right? Apple is can be represented as 5, 5. Banana can be represented as 6, 5. So that's how they are grouped. Fruits are grouped closer to each other because they come under the same category, and the games, the balls, as you can see, tennis, basketball, and soccer, they come under balls. They are grouped together closer to each other, and automotive like bicycle, um, truck, and car, they are more similar. Automotives, they are grouped together. So that's how the objects are stored in a vector database. So like you see, right, it's again the same example. Pawan is a developer evangelist at SingleStore. Each word is it's a big sentence. It gets chunked, and each chunk is assigned with a numerical value. And all these vector embeddings are stored in a vector database. Okay, and yeah, again the same thing. External data gets split, and data uh, they are split into chunks of words. That's what we call tokenization. And every word is assigned with a numerical number. And then that's how vector embeddings are created. All these vector embeddings are stored in a vector database. And like I said, right, the similar objects are placed closer to each other in a vector database. And what if when a user query comes in, we also need to understand how the vector database, how the process works, and the similar chunks are retrieved back, right? That's where uh, we have these techniques like semantic search, vector search, right? So this is about cosine similarity. Uh, Again, dog, puppy, they are more similar. They are placed closer to each other, and when the things are unrelated, right? dog and car, they are unrelated. That's how you can represent them. And the opposite is completely opposite. Uh, one is shoe. Example A point is shoe, and the B can be milk. So they are apart. So there are different techniques to calculate the distance between these vectors. Euclidean distance, dot product, semantic search, all this. So traditional versus vector databases. You might ask like how traditional databases are different from vector databases, whereas it's all about the how data is stored, right? Data is stored in columns and in a proper format in traditional databases, right? Rows and columns format. Whereas in a vector database, the data gets converted, the unstructured data, even structured, unstructured, any type of data gets converted into vector embeddings first, and these vector embeddings are stored in a vector database. So that's the difference. And yeah, again, like I said, right? Various it can take various inputs, the structured, unstructured data, which goes through an embedding model. Using an embedding model here, text embedding ADA002 is basically from OpenAI, and that's how vector embeddings are created. Basically, all this data gets chunked, and each chunk of word is assigned with a numerical value, and then that's how vector embeddings are created, and all these vector embeddings are stored in a vector database. Okay, and so how large language models get you know different from RAG. So as you can see here with a simple example, in a college, you might have given a project on solar system, right? Write an essay on solar system. So what LLM can do, sometimes also it can hallucinate if you take a help of LLM, right? It can write an essay on solar system. The solar system is a collection of this, that, and all, and sometimes it can also hallucinate. You don't know if the answer is correct or not. But whereas RAG has a specific key, right? It has a library and a specific enriched data that is already present in a vector database. It's easy to retrieve the proper results, right? So if you ask a specific question to RAG, how many moons does Jupiter have? It can easily say Jupiter has 79 moons. But the same thing, if you ask an LLM, it might answer to fail. It might fail to answer. It might fail to answer. So that is the difference. So that's why retrieval augmented generation is kind of very important to augment custom data in your through your vector database. So yeah, LLMs use case, you can use these LLMs for content generation, summarization, translation, classification, and chatbots, right? So examples of LLMs: GPT by OpenAI, Lambda by Google, Llama by Meta, and Cloud by Anthropic. These are some of the LLM examples, and yeah, I wanted to talk about SingleStore because SingleStore is one such data platform. It supports all types of data, right? And it started supporting uh, vector storage long back in 2017 itself, right? So SingleStore database delivers built-in similarity search on vectors to add memory for your generative application. So using SingleStore, you can build hyper efficient and enhanced generative AI applications basically. Like I said, right, it started supporting vector storage long back in 2017 itself, and it has SingleStore has a good integration with all these AI frameworks like Llama Index, LangChain, and yeah, you can go to if you're interested in trying out SingleStore. You can go to singlestore.com. SingleStore has a free share tier. You can use it free forever and just sign up, try building a database, try to load some content, and we have even SingleStore has different tutorials where you can try how SingleStore can be used as a efficient vector database and all that. So hope you understood this complete presentation or video on generative AI for beginners. Let me know if you have any questions. I can answer them. Thanks.